session of the day and the 8th session of this FDP. Sir has already joined. Devashish sir, can you hear me?
Yes, madam, I can hear you. Yes.
All right, sir. So, sir, with your due permission, shall we start this session?
Yes.
All right. So, to all the participants, the topic of this session is machine learning meets privacy in 6G mobile network. The talk will be given by Dr. Devashish Dev. And over to you, sir. We are eagerly waiting to hear more from you.
Thank you, madam. Thank you, everyone, for being with us. And initially, I will just try to cover some of the parts that we left. And there is a continuation between these two topics. So, the 6G is a very important technology coming up. Rather, you can ask me why I am talking about 6G in the 5G era. Because 5G has already come in various parts of the world. And unfortunately, India is still striving. We are having 5G mobiles, but 5G network is not available, with us because of various technologies compatibility. We are talking about Indian 5G, right? Similarly, Indian 6G is about to come, but another 10 years maybe. But surely next year 5G we are looking forward. Because of this 5G, the bandwidth is very high, network speed is extremely high, and we can download the full movie within few seconds. And the network bandwidth and the system property will become very efficient. And that is the reason that we are actually will be talking about these 6G technologies, how it will be helping. Not only 6G, are some of the 5G technologies also as well. 6G is just like a top up of 5G. So we'll be discussing those techniques, how to make the system secure and how to preserve the privacy, because privacy preserving is very important. And machine learning, whatever we are learning, that must be privacy preserved. Otherwise, our whole system will become at a toss basically. Because we are disclosing all of our data, including our health data. What kind of disease I have, if any one of the participants know, it is not good for the society, right? So, privacy preserving healthcare, privacy preserving drone technology, that we'll discuss today. So, before I start, may I ask anyone that you heard about anything about the privacy preserving machine learning, PPML? We call it PPML, privacy preserving machine learning, PPML. And today, this year is the third year of PPML, third year of this technology called privacy preserving machine learning. Okay, this is I think no. Okay, anyone? So anyone heard? Then you can unmute yourself or you can chat in the chat. No.
Sir, in the chat, the answers that we are getting are on notes.
No. So good. That is good. I am happy. At least I am giving you something new for next 1 hour. So yes, I can introduce a term to you. It's called. I am writing it also in the chat. Federated learning. This is known as federated learning. Who started? Answer is Google. Google started this federated learning in the whole world. This is called privacy preserving machine learning. And what is that actually? In your mobile phone, whatever you are typing, whatever you are writing, NLP, right? They are using NLP, natural language processing. Using this NLP, say our Majid Basi sir, right? If I ask you, what do you mean by A for? Majid Basi sir? Or anyone? Bharvi Ghosh, madam?
Yeah, actually, Majid sir has written in the chat box, A for Apple. The first
A for
thing
Apple. Okay. Yeah. Anyone A for anything? You can write arbitrarily. If I ask you A, what is in your mind? Everyone type. Please type. I'll give you the answer after something. Yeah. Someone has written aerophone. Okay, good. Any other? And okay. What you type in your WhatsApp? Just come to WhatsApp. What you type? When you are using WhatsApp, what do you type in your WhatsApp message? A for anonymous. Artificial intelligence. Yes, good. Today's topic, artificial intelligence. Anyone? Me? Okay. If I ask you, say G for good morning, right? Everyone see this message, right? G for Gmail, okay. G for good morning is very popular. Very popular. I'll give you the answer of this question. Any other person? Any? Everyone please type G for what you write. Within 30 minutes, I'll give you the answer. What is the meaning of it, right? G for God, yes, correct. Why you are afraid of writing? Right, yes, game. Everyone should interact, take part. Yes, game. Great learning, great. So what you write in this WhatsApp? Great learning. Okay, good, no problem. God, Google, game, good, yes. We use good frequently, right? Yes, correct. Any other? I'll give you the answer of this question. I'll show you why I'm asking this question to you all. So it's a very interesting one, and I think you'll be happy to know that how this privacy preserving machine learning works, right? Grant, yes, correct.
Theory lecturing hours.
Yes. Great. Okay, fine. I got some sufficient answer for G. See, everyone is writing more or less different thing. Only one person written good. I think I was expecting everyone should write good, but that G for good, G for God, whatever. Don't write artificially. What is in your mind? G for what? G for goat or G for king, whatever you write. No problem. Okay. Global. Okay. Gray. Grill. Curl. Okay. Fine. I'll give you the answer of this question. Okay. Let us first finish this part, and I'll come to that this answer of your question. I've mentioned that I'll be discussing federated learning, which is a new kind of learning technology, and which is popularly used in research and in your practical life. Even in your WhatsApp message, Google keyboard, we use federated learning, right? See, these two drones want to talk to each other. This drone is talking to this drone, right? Must have their own privacy, right? They will disclose, they will talk, but they will not disclose what is their own private things, right? So this is the important, that privacy preserving is important. So if you have your own drone, like many people have their own dog, okay? Similarly, there are many people will have soon their own drone, and drone has all information. Drone has your all information, okay? All means all. What time you eat, what time you go to sleep, because that time drone will go to idle mode, right? What is your BP? What is your average triglyceride in your blood? All the informations, various capacity from various healthcare, from various fitness point, how much push-up you can do during exercise, how much kilometer you walk every day. This everything can be tracked or rather tackled by this drone. So drones must be privacy preserved drone. I'm repeating, drones must be privacy preserved drone. It means drone must not disclose our own data. It is only giving to the to the authority. Authority means it can disclose your health data to my hospitals. So, for example, I'm a patient of Amri Hospital or Medica Hospital. So it will go to the hospital and disclose my data, not to Tufan sir, not to Varvi madam, right? Not to Nilanjana madam. So this is very important. So making your own drone, customization is very important. So customized machine learning, listen, I'm repeating the term. This is known as customized machine learning. Customized multi-objective optimization. Say the 15 parameters, what I like, maybe the set of 15 parameters different from Tufan set, right? Maybe 15 parameters is different to Barbie madam, right? And maybe 15 parameters different to Nilanjan madam. Maybe someone is using only 10 parameters. So parameters are different and varying band to band, human to human. So when you are talking about social IoT or citizen-centric computing, then these protocols are very important. These protocols are very important. These privacy-preserving protocols are very important, right? So I'll be discussing slowly how we have to make these drones intelligent, sometimes by using this machine learning, sometimes by using this privacy-preserving, federated learning, using this 6G and 5G speed, we can make the system much more stable for the society. Okay, so slowly let us start. So I've covered this part, so I'm not going to the performances. So these are the various calculations we did. So you know that when you are talking about grid network, power grid. Last year we have published in August in International Journal of Parallel Programming, where there are power grids. You have to connect the power grids. So each and every power grid there is a power failure. This drone will go there, and they will, with a relay race, drone will provide the power, lightweight power, or less amount of power, but there will be no full dark age, right? So this kind of drone things are work in the power grids area. This is the model what we have shown, that we did some experiment, modular experiment, and the area where the power is down, these drones are moving to those areas. In a relay race, they are just like a power applications, 1, 2, 3, 1, 2, 3. They are connecting the power grids with low power, not very high powered system, but with a low amount, so that at least one bulb of your room can be operated. At least one fan of your house can operate. So in some emergency cases, these intelligent power grids are actually helpful. So this area of work is called I for intelligent power grid operation, or grid for edge drone. So this is the title of the paper, where we have provided the power to the remotest areas. So if you're interested, they can go through our paper, and any problem we can discuss. Okay. So also we have developed some lightweight, sustainable, intelligent load forecasting. If you can forecast the rain, today is going to heavy rain, right? Accordingly, we will take the precaution. So if we can intelligently measure the load of the system, so we can also do some power grid applications. So we did this forecasting applications for sustainable computing. This is also, the journal name is also sustainable, Elsevier, where we have worked in this domain. So to provide the sustainable power grid operations for the systems to operate. Okay. So we are all doing this Python-based machine learning, and we are using this programming in the Python main module, and we are leveling the data. And this is the total architecture, how we are actually doing the training data set, how we are doing the machine learning, privacy preserving machine learning, and these are the operations actually happen, right? So this is some of the pictures, some of the snapshots in our field work. We did it practically, so I was really interested to show you. These are the modules. This is the indoor module, and this is the drone, everyone know. And these are live sessions, right? The copter. This is one of our students who is actually Amorto, who is from IIM. So there are various applications, like that using these drones we can control the remote controller. Using this tablet we can control the drones, and it can be controlled drone. I have already mentioned that it can be autonomous drones, right? Not only this controlled drone, but also we are using this underwater drone. This is available in Amazon. Sometimes it is available, sometimes it goes out, but most of the times it is available online at the cost of around 73,000 Indian rupees. Drone can go in deep in the sea, and they can capture the data, and there are various sensors are there, various lights are there. So those who are interested, they can connect these sensors, and also this drone has the capability to connect with this kind of drone, means on sky drone. So on sky, also in the underwater, it is called UAV AUV network. UAV AUV network. This is AUV underwater, and that one is UAV. So AUV UAV network is like this. So I'm not going in detail because it will take a lot of time. So this is a paper we did called Internet of Underwater Things, May 2021, means this year, May. Modeling and simulation of drones using software-defined smart underwater things, means smart Internet of Underwater Things. We call it smart Internet of Underwater Things. So everything in the water we can identify using this say well-known algorithm. We have not written our own algorithm. We can take your existing algorithms. But what we did the process integration, integrating various algorithm, and we captured the data, and we have developed the model, because integration is very important. Information fusion is very important, right? Because information fusion is very, very important for multi-sensor fusion, because we have underwater sensor, we have on board, means on the land sensor, on the sky sensor. These sensors must work together. So fusion of signal is very important, very challenging, very challenging. We face a lot of problem. We have to do a lot of communication technology. We have to take the help of the electronics engineers, and ultimately we have developed a software-defined module. Using this software-defined network, you know, the SDN is very popular. Using this SDN, we are connecting this all layers, underwater and tops. Okay. So those who are interested, they can go through this paper and they can get a detailed idea of it. So these are some of the references. So drone with chain, blockchain also very makes the system very secure. So today I'm not going into the security domain. Now very important, the traditional AI also is bio-inspired network. Bio-inspired network is playing a major role, especially in evolutionary approach. So I'll show you some of the evolutionary approach, what we did for last 5 years. Yes, last 5 years, 2016 to till date. We have used reverse GSO algorithm. Glowworm means, you know, that this is a, we call it Bengali, we call it Jonaki. So glowworm. And glowworm, there is some light comes out from the backside of the glowworm. And this glowworm, glowworm makes a cluster. And you know, when there is a light, glowworm goes to that area. When there is a light, what is the property of the glowworm? Glowworm will go to that area. So, but in this case, I've used reverse glowworm. Means when there is less energy, the glowworm will go to that area. That will make the system energy optimized. Okay, I'm repeating. We did reverse glowworm operation, which makes the system energy optimized. Okay, we published in SIMPAD journal, Simulation Modeling Theory and Practice, elsewhere. So this is the first work we did, reverse glowworm, using this mobile wireless sensor network, right? This is the glowworm, and clear reverse glowworm operation. Anyone? Little bit difficult concept, sir, or anyone? What is glowworm? Glowworm moves towards the light. What reverse glowworm means? It is moving away from the light. Means reverse. When there is energy, if there is energy less, energy constant, the sensor will move to that area. That is a very important, because we want 100% coverage. Ultimately, we have to give the coverage for the full city. So, if someone is ill or someone has low power, so we have to provide the power to that area only, right? That is the reason we are using reverse glowworm. Is it clear?
Yes.
Okay.
Yes.
It is the first time we did. You know, this is our first. You know, what you can say, that proposition, and just it is doing the inverse operation of the glowworm. But using this, we got very interesting results, and we can develop the drones using this glowworm system, right? I'll not go through the mathematics because it will take a lot of time. So those who are interested, they can, I can share the slides. No problem. So they can see it is providing energy efficient sensor movement by reducing the energy consumption due to the movement of the sensors. Okay. Because it will reduce the number of overlapping, and by using this reverse glue arm, we can achieve the very high efficient system. Okay. So reverse GSO is very popular, become very popular after our work, right? So yes, one of the best advantages is that we can reduce the power consumption, but we can also increase the coverage area. That is very important. I'm not going in the mathematics of it, but this is the power calculation. This is the probability of movement. This is the coverage, how the sensors move. Okay, I'm not going in the details of this mathematics, but it is just one kind of PSO algorithm. We have also similar P-based, G-based, position-based, global-based. So using this, the sensors can move. This is a grid where all the grids must be covered. We have to give the coverage to all the grids. So we have to design our algorithm in such a fashion. We have to provide the.
Sir,
Yeah.
sir, there is a request for you from Prabhupada sir that if you could display the paper name for the title of the glowworm again, so that we can.
Yeah, I will show you. Madam.
Okay, thank you, sir.
So these grids, these are doing the coverage. Coverage is very good. It is coverage almost 70-80%. 100% is never possible. At least 70-80%, 90% is fine. So we did this simulation in MATLAB, and some of the scientists they did practically. Okay, they put our system practically. So these are the energy modules, and it starts from equals to half mv square. This is very Newton's law, right? And we did some energy optimization algorithm. I'm not going in detail because that is not our point of discussion. We've seen that we have done very good coverage and we have reduced the energy. And we have did various case studies, and we have outperformed the previously published 2011 paper, Leo's paper, and we got very interesting results of this. Okay. Yeah, you want to see the paper, right?
Yes, Prabhupada sir has requested.
Yes, this one. Please copy it. I will share you the slide, no problem.
All right. Okay.
Madam, I will share after the lecture. I will share you the slide.
Okay.
So this we did in 2016. Okay, reverse glue arm operation. Now some of the scientists work in the drone. Our today's lecture was drone and privacy preserving, right? So these people of Ali Khan and Aftab Zehan, China, and all from China, they have made a self-organized cluster for flying ad hoc network using GSO, and they have cited our paper. Very interesting. And this paper, they are talking about flying ad hoc network cluster using GSO. Okay, and this paper they have discussed how this flying ad hoc network operates, and they have used our GSO instead of PSO in the reverse operation, so that clusters can cover the whole area, right? Clusters means cluster of drones. They can cover the full area. Okay, that is our target. So these are the working principle I am just keeping. Also, this last year we have worked on one area called reverse glue arm for movement score based limited grid mobility approach for reverse glue arm operation. Okay, this is published in ad hoc network, where we have worked in the swarm optimization, glue arm swarm optimization for optimizing the path of the swarms. And by the way, we are optimizing the path of the sensors. Sensors means UAV as a sensor, right? Because UAV has lots of sensors in it. So I'm skipping this movement pattern. Recently, also this year, we have worked in ComCom, where we've used fuzzy logic and we got better result. And it shows energy efficiency, very good energy efficiency using this GSO. Okay, it published in Computer Communication, where you know that we are using fuzzy logic, we are using genetic algorithm, we are using GSO, in the drone operations. Why? Ultimate aim is to make the system efficient. Ultimate goal is to make the system multi-objective optimization. Right? So anyone is interested, they can go through it. Details are given. So we have simply used our fuzzy rules. Fuzzy logic is well known to everyone. So fuzzy logic helps us to optimize the whole system, and we have developed this fuzzy model using MATLAB, simple MATLAB. I think MATLAB is available to you, or you can do it by Python also. So I'm not going in the mathematics, I'm just skipping it because of shortage of time. So yes, but see, very good coverage. Using this fuzzy model, we get very good coverage. Coverage area is very good. Okay. Coverage area is very good. We got very good coverage using this fuzzy model. Someone is using some multi-objective optimization models also. You know, there are a lot of people are working. This is an open area, new area, so people are working on it. How to utilize this GSO model or any other bi-inspired model, because bi-inspired models are very much optimized because it is nature itself is optimized, right? Nature itself has some optimization techniques, right? So our animals move in the optimized mode, so we get very good result in the fuzzy mode. Okay, details are given in the paper, and this is a MATLAB plot. We did this swarm plots, and each and every nodes are basically plotted like this, and sensors move in a reverse GSO format. That means each and every point is nothing but a glow worm. Okay. So these are the sensor movement. Another point we have observed is called Voronoi diagram. So if we give a square diagram or this kind of thing, we cannot give coverage. Sometimes we have, you know, those who are from mobile network, we give hexagonal structure, right? But Voronoi structure is very important. Voronoi structure is very, very important because in this Voronoi structure, the shape is a geometrical shape, basically coming from trigonometry. This Voronoi diagram gives a, you know, arbitrary structure based on the coverage. So by this way, we can almost get 100%. I cannot say 100%, but almost 95 to 99% coverage. So we try to use this Voronoi diagram as a new concept to cover the whole area in that areas, you know, in the coverage zone. So each and every black point indicates the glow worm, and it is trying to cover dynamically. It's programming in the whole system. So Voronoi diagram is, see, there is no gap. So this point can cover whole area. It need not to be a circle, need not to be a square, or need not to be a hexagon, right? This is the beauty of Voronoi. So if there is a, say, this swarm is nothing but a salesperson or pizza delivery boy. This pizza delivery boy have to cover this whole area. If someone is from Domino's, give an order in this area, this pizza delivery boy will give the order in this whole area. So this person has that license to move in this area. But in the next pizza delivery boy, they can move to that boundary. So everyone has their own zone boundary. So they can move in the zone boundary area based on this Voronoi diagram. This is another very interesting area which I got from the you know computational geometry point of view. Okay. So some of my mathematics friend, he was working, I just seen, and we are working on this topic. So this is another thing which shows the coverage. Very beautiful picture, which is showing the coverage of the drones in the smart city area. And see, there is no gap. Beauty of the Voronoi is there is no gap. Only some perpendicular lines are there. So it can cover full area. And that is the reason Voronoi diagram became popular. Even I will show you for the drone lighting system. Voronoi diagram is very much used. This Voronoi diagram, earlier it was like this. Nowadays we are using Voronoi, right? So have you seen the drone lighting system in the Olympic? Anyone? Olympic? Anyone seen Olympic drone lighting system? Drones are moving on the sky, making Olympic symbols or signs. So circle becomes oval, oval becomes circle, or this kind of symbols. So drones can move, and using this GSO pattern or using this Voronoi diagram, we can make this kind of pattern mapping. So this is a visualization how the drones are moving and making this very beautiful lighting systems, right? So see, these are the various patterns actually I'm not going in the details of mathematics because it is complicated mathematics is involved. But without mathematics also, simply you can use this diagram and you can go for 100% coverage. Okay. Forget about mathematics. You can use that mathematical model and you can go for this full coverage. Ultimately, our aim is to cover the full city, right? Means service. We have to give the service coverage. This means service coverage, not the power coverage. Mind it. This is called service coverage. Is it clear? Service coverage.
Yes, sir.
Means this is the boundary area of the drone. This drone will provide the service in this area, like a pizza delivery boy I have mentioned, right? So this is the service delivery model, and Voronoi diagrams are becoming much more useful. And this is not new, but I have used in this Voronoi for first time for global models. Okay. See how this coverage is actually happening. Right? So Voronoi can, fill up these gaps. Gaps are not permitted. So see the coverage. So I'm not going to mathematics. So the lighting systems, what are the street lights or lighting systems? Node modulation can be done. Node modulation means node movement. How the nodes will move. I've mentioned the boundary of the node zone. So nodes can move only within the boundary. Glow arm means it is a freely moving object. Our UAVs are freely moving object, but the drones should move within a certain boundary. That boundary region is very important. Okay, this is the thing you understand. Everyone has their own boundary. If the second node fails, then only the first drone will come to the second zone. That means if one pizza delivery boy meet an accident, unfortunately, then it will make a request to the second pizza delivery boy. Okay, I am not ill because Domino's, how much minutes they provide the service? Anyone?
I believe it's 30 minutes. Within
Yeah, 30 minutes, 20 minutes. Yes, you're correct. So you have to provide the service. So that's the time, unless and until the backup comes, this service will be provided. So this is the beauty of the whole Voronoi diagram. And this is very much useful nowadays for the drone delivery applications. See, this is the drone movement, the coverage. Very beautiful diagrams. And this is published by some Chinese scientists. Japan. They did it from the lighting system of, this UAV movement. See, the UAV is moving in the certain boundary only. It should not move outside the boundary. Little bit allowed, but mostly they have to confine within the certain zone. Okay. See, this is a beautiful thing. This is the lighting system. Using this in our Kali Puja or Diwali, we make a lot of pollution, right? Agree or disagree?
Absolutely agreed, sir.
So, if we can buy the Diwali light with, it is an appeal to all the participants. If we can develop for our society the Diwali-based lighting system, means using these drones, we can do beautiful lighting system, right? These are the numbers, these are the symbols. I've shown you how this morphing. You have heard about twinning, morphing. We can make a lion. We can make a cat, animal, right? Everything we can develop. So these are the movement of the drones. By it can make a circle, it can make a triangle. See, these are the drones with light. Like a little star. Drones are moving on the sky. The twinkle, twinkle, little star. So drones are moving on the sky and they're making beautiful pictures. Like the bird, like a person is moving. This is already done. Nothing new. But what is my observation? What is my thing is that we are also working in this optimization of this algorithm. That is not much done. It's done, but that can be done better. So that we can get this kind of beautiful birds and we can celebrate our Diwali pollution free. So drone mobility patterns, drone direction patterns, very interesting things we can do. Drones are also helpful for doctors, right? Medical doctors. So drones have a lot of application during this COVID. It's one of the slide I got from internet. So there are COVID applications. There are hundreds of applications. I'm not reading because I'll not go through it details. But COVID application drones are extremely helpful and that helps the smart city to recover from this COVID accidents. Still it is on, but people are trying to optimize, especially for delivery of the products. I've given the face recognition and many other things, right? So I'll share you the slides. They only can get a detailed information about it. How these drones are helping the smart cities to fight against the COVID, right? So there are some pictures. I don't know. If you go through the YouTube, 3D lighting systems, right? If you go to the YouTube, we can click this link. I think it is not activated now. We can get a very interesting lighting system. For the shortage of time, I'm not showing you the lighting. Madam, can you share the one lighting system? Is it possible? 3D lighting system using drones or Tufan, sir?
Yes, just hold on, sir.
I'm not.
I think you can also share.
Okay, I'm sharing that. Sometimes I wait a minute. I'm
Okay,
trying to
sir.
share it now.
You can paste it in the chat box, and I'll run it from my end.
Yes.
Just a second.
Profullo B mentioned the problem statement. Yes, this drone optimization in Voronoi still is a new area. We can work. We are working. We can join hand. No problem. Profullo B, madam. Sir, Profullo B.
Sir, I'm taking over the screen sharing to share the video.
Yes. Please stop my screen.
Is it visible, sir?
Yes, sir, it is visible.
What started as a platform for hobbyists is poised to become a multi-billion-dollar industry. Inspection, environmental monitoring, photography and film, and journalism, these are some of the potential applications for commercial drones, and their enablers are the capabilities being developed at research facilities around the world. For example, before aerial package delivery entered our social consciousness, an autonomous fleet of flying machines built a 6-meter tall tower composed of 1,500 bricks in front of a live audience at the Frac Center in France. And several years ago, they started to fly with ropes. By tethering flying machines, they can achieve high speeds and accelerations in
this
very
drone
tight
is making
spaces.
a bridge.
They can also
How beautiful
autonomously
it
build
is,
tensile
right?
structures. Skills
This
learned
is the one
include
problem
how to
statement.
carry loads,
You can
how to
develop
cope with
this.
disturbances,
See,
and in
bridge.
general, how to interact with the physical world.
Huh.
Today, we want to show you some new projects that we've been working on. Their aim is to push the boundary of what can be achieved with autonomous flight. Now, for a system to function autonomously, it must collectively know the location of its mobile objects in space. Back at our lab,
Yes.
So all the participants, if you see this, you know that if you want to move to one part of the hill to other part of the hill, then to develop the bridge is very difficult. But if you see this picture, you know the drone can break the go to one part to other part, and they can make a easily bridge. So you have to design your own algorithm. How to make this switching and stitching, right? These drones are making this, right? So please start. Yeah. See, there's some of the applications, very interesting applications. This is the Andre Rafalo. He has done majority of the achievements of the drones. Yes, please.
Okay, sir. I'll continue from
Yeah,
where
yeah.
we reached.
Studios, a spin-off from our lab. There are no external cameras. Each flying machine uses onboard sensors to determine its location in space and onboard computation to determine what its actions should be.
He will
The
show
only
you
external
some autonomous
commands are
drones.
high-level ones, such as takeoff
Let's
and
see.
land.
And he's just thinking the drone is moving. He is just thinking and the drone is moving. Can you believe it? It's called thought drone. It is made of BCI, brain computer interface. BCI drone, right?
This is a so-called tail sitter. It's an aircraft that tries to have its cake and eat it. Like other fixed-wing aircraft, it is efficient in forward flight, much more so than helicopters and variations thereof. Unlike most other fixed-wing aircraft, however, it is capable of hovering, which has huge advantages for takeoff, landing, and general versatility. There is no free lunch, unfortunately. One of the limitations with tail sitters is that they're susceptible to disturbances, such as wind gusts. We're developing new control architectures and algorithms that address this limitation. The idea is for the aircraft to recover no matter what state it finds itself in. And through practice, improve its performance over time.
So he will show you a lot of drones. You can just skip.
At the heart of the matter.
Yeah.
For example, one such question would be,
or
what is the minimum number of moving
Yeah, wait,
parts needed for
just show the
controlled
basic
flight?
drones. You
Now,
can
there are
sometimes.
practical reasons why you may want to know the answer to such a question. Helicopters, for example, are affectionately known as machines with 1,000 moving parts, all conspiring to do you bodily harm. It turns out that decades ago, skilled pilots were able to fly remote-controlled aircraft that had only 2 moving parts, a propeller and a tail rudder. We recently discovered that it could be done with just 1. This is the monospinner, the world's mechanically simplest controllable flying machine, invented just a few months ago. It has only 1 moving part, a propeller. It has no flaps, no hinges, no ailerons, no other actuators, no other control surfaces, just a simple propeller. Even though it's mechanically simple, there's a lot going on in its little electronic brain to allow it to fly in a stable fashion and to move anywhere it wants in space. Even so, it doesn't yet have the sophisticated algorithms of the tail sitter, which means that in order to get it to fly, I have to throw it just right. And because the probability of me throwing it just right is very low, given everybody watching me, what we're going to do instead is show you a video that we shot last night.
You can skip some of the.
Okay.
Yeah.
The thing to notice is that it is highly symmetric. As a result, it is ambivalent to orient the interacting flows from its 8 propellers. Some of this can be modeled, while the rest can be learned on the fly. Let's take a look.
Please go to the end. And,
Okay.
nearly
Nearly
little bit more, little bit.
Reliable.
Just
They're going to
50%
enter part of our daily needs.
Okay.
This one wants to spin clockwise,
50%.
this other one wants to spin counterclockwise. When you put them together, they behave like one high-performance quadricopter.
So this is one of the light-based drones.
If anything
This is
goes
one of the
wrong,
light-based
however, a
You just
motor
keep it-
fails, a
you just keep
propeller
it-
fails,
Okay.
Another 2 minutes, you go. 2-3 minutes.
there's a new palette for aesthetic
Yeah,
expression.
now they see this one. This is
We've
very,
taken
very good.
commercially available micro-quadcopters,
This is the light drone.
each weighing less than a slice of bread, by the way, and outfitted them with our localization technology and custom algorithms. Because each unit knows where it is in space and is self-controlled, there is really no limit to their number.
This is GSO algorithm or PSO algorithm. This is PSO. Just look at it. This is a swarm algorithm. One drone is following the other drones. Can you see this? This is one kind of swarming. He has started one drone, but other drones are actually moving towards the following the other drones. You'll come back to the same 0 position. Okay. See, it is moving again. You'll come to the 0 position. So it can take any kinds of design. I have already shown you using the Voronoi or in any other technology. Using you can design this kind of drones. Only thing you have to program it, and this one drone should know what is the exact location of the other drone, and then only they move like this. Okay. Okay. Thank you. Thank you. Tufan sir, you can close it now.
Okay.
Yeah. Thank you. So I think you got some idea. Now it is all up to you how we want to develop algorithm. Algorithms are very important. You have to develop your own algorithm, right? 1 minute.
Sir, we are not able to see your presentation.
Yeah, I'm just sharing. Just sharing my screen.
All right.
Is it visible now?
Yes, sir. Yes, sir.
Yes, visible.
So I had one small query.
Yes,
Like
yes.
when these drones are actually communicating with one another, how is exactly they are able to know the exact distance? Because this won't happen with GPS or any other technology. Because
See,
GPS.
there are various tagging technologies are there. It's called collision-based computing. It's a very interesting area.
Okay, sir. Okay.
So this is known as collision-based computing. Collision-based computing. So you have to avoid the collision. So collision avoidance algorithm we have to develop. Already there are hundreds of algorithms out there, which is known as collision avoidance algorithm. Mind it.
Okay.
There is some geotag-based algorithm. There is some that never to if you can remember in the starting of my lecture, previous talk, I have discussed that two drones should not collide to each other.
Yes, sir.
That was the vision of PwC. Each and every line was very important, right? So drones should not collide. If you see the birds are moving on the sky, they never collide. That is the beauty of GSO or PSO algorithm, particle swarm optimization, right? So those kind of swarm optimization algorithm is actually inbuilt in the full system. So drones are not working. One drone is not working. Whole drone system is working, right?
Right, sir.
Clear? The
Yes,
concept.
Yes, sir. Thank you, sir.
It is not one drone. It is a cluster is working. It is a team working, right? See,
Right.
today I am giving lecture in front of 78 audience. But you know that all credit goes to you only. I am the authority. Those who worked in this project to develop means to hold this workshop, right? So a full team works, right? Someone is a speaker. You are also managing the Zoom link. The participant also very important. They have participated. So whole ecosystem should work, right? Similarly, the drone system is totally ecosystem. It's not alone. It is not individual, right? Clear?
Okay. Yes, sir. Absolutely.
So I've written this a little bit in a interesting way. Have you seen the movie Jab We Met, right? A very famous movie, Jab We Met. Anyone seen it?
Yeah, I think many of us have already watched.
Yeah.
Yes.
What is the English of it? Jab We Met. I think something like When We Met, right?
When we met, yeah.
Isn't it? So my title is now inspired by that movie. Okay. When machine learning meets privacy. Okay. Generally, if you see my all research papers, most of the research papers are either inspired by movies or by song or by some poem or something like that. This title also, I just want to just fun, but you have to learn with the fun. Then only you can understand, you can remember. At least for me, I remember like this. So when the machine learning meets the privacy, okay, in 6G mobile network. Yes. When it meets, because I have mentioned privacy is very important. Without privacy, our system should not work. Our currently machine learning is privacy preserving machine learning. I told you, you have given some answer ABCD like this. So you know that in the 6G network, we are moving in ultra speed, gigabit per second. 5G is giving 10 Gbps and 6G is giving 100 Gbps. So high speed we are talking about, right? It is extremely high, isn't it? And we are covering and we are providing the IoT solutions in every corner of the world in a very high speed manner. We are providing these drone services. We are providing the services to the whole city and the whole country and the whole world, right? So there are some research paper magazine there from this picture. I took this picture from there. And yes, by 2030, 6G is about to come. And 6G is promising by Internet of Nano Things, nanotechnology and 6G will merge. Also biological things, human being will be also merged with the network. Okay, will be also part of the network because some biochips will be part of the body and will be also controlled by the system or will be controlled by the system, right? So this is the vision of 6G, that how we can grow and we can make secure 6G network, secure 6G network. And security is provided, if you provide the security and machine learning separately, right? Then its system becomes complex. Agree or disagree? Security and machine learning, various security protocols, blockchain and many other things, right? Yes. But if you give security and machine learning in different manner, the system becomes very complex. But we cannot develop so much complex system. We have to do real-time operation, right? Real-time operation. We have to develop a secure system. So in order to develop the secure system and with a very high-speed network, I'm not going into details, but we have to go for the role of machine learning is very high. Okay, in 6G to provide the machine learning based communication. Communication will be also machine learning based, which is not even available for 5G network. Machine will operate. Whatever the requirement, machine will decide, right? Machine learning models in 6G is computing the systems and are used to learn the characteristics of the system in a mathematical model. There are various mathematical models out there. One of the model I will discuss. We know already supervised, unsupervised, reinforcement learning. I'm not going in detail, but reinforcement learning is, of course, is a very important process of learning because it is a reward-based learning, right? If you are doing good, you will get reward. Otherwise, you will be punishment. Just like a children, after a baby born, they learn through the process of, the process of, that by mistake, learn by mistake, right? So by this process, reward and punishment model. So this reinforcement learning is widely used in this credit learning system or centralized system. So 6G basically uses types of learning: centralized learning for group-based, distributed learning for edge-based. I'm repeating, distributed learning for edge-based network. So we are providing edge intelligence. There is a term called edge AI, edge, EDGE, edge AI, right? Edge AI will provide collaborative learning. Means we are all learning, right? You are asking the question in this platform. We are having interaction, right? So Tufan sir also asked some very interesting question, how these things operate. I think many other madams also asked very interesting questions. We are learning together, right? When the system learns together, the system becomes stable. Otherwise, what will happen? If I give a lecture and I finish, no question, or at the end question, then system becomes boring, right? So collaborative learning is one of the very popular learning, and federated learning. Federated learning means learning at the edge. Okay, so I'll show you. Last is split learning. We are learning the various stages, and we are combining at the centralized zone. It's called split learning. So 3 types of learning. Please remember, 3 types of learnings are used for 6G network: collaborative learning, federated learning, and split learning. And the middle one, federated learning, is nothing but PPML. privacy preserving machine learning. What is that? The centralized learning. I'm not going. Centralized learning means all the sensor, fog, ultimately going to the cloud. Central cloud is residing. It's not so much useful. We are talking about distributed learning. Every system has their own machine learning. Whether it's a laptop, whether it's a mobile phone, everyone can learn. And ultimately, a collective learning model goes to the cloud. So this is known as like a distributed database. Distributed learning models are there, right? This one is more beautiful. The learning remains on your device. So this is the device of say Tufan Shah. This is the device of say Nilanjana Dr. Roy. This is the device of Devashish De. So whatever the learning is happening, the learning remains with me only. Right? The learning remains with me. Only some gist will send, not the full thing. So our privacy is preserved. Our privacy is preserved. I will explain it slowly. Our privacy is preserved because learning remains at the edge. Okay. So this is the most popular kind of learning technique nowadays for 6G called federated learning. So that title, Jab we met, that means Jab federated learning made 6G network, then the network becomes privacy preserving, right? I'll explain it slowly. Give me some time. So see, there are some mobile phones and some learning. You know, if you are writing in your keypad of your WhatsApp is so popular. So if you're writing some your keypad and there is some mind models are there. Initially some models are there. Model means learning model. What kind of learning model in a keypad? Anyone can say? In a mobile keypad, what kind of learning models are there? It is NLP, natural language processing, isn't it? I think you have seen the recently you have observed anyone that if you are writing A, then apple is coming. If someone writes B before bag is coming, but same A is different. For say Tufan is writing A, then he is getting again or all. When Devashish is typing A, we are getting apple. Why it is different? Anyone?
I believe it is, sir, it is based on the most number of words that the person has typed starting with A. Learning from that, the system is predicting the most frequently used word.
And basically, like
Yes, you are right.
It's a predictive learning.
Yes.
Basically, it's a predictive learning based on all the past experiences.
And very important that whatever the word Tufan Shah is using, what are the words Babri Ghosh madam is using, or what are the words are used by Devashish De, it is not disclosed to the Google. It is only your part, your life, right?
Correct. Yes.
So this is called privacy preserving. Your privacy is preserved. I have given a simple example of NLP, but this can be applied to many other aspects, right? Many other cases. Clear? Now,
yes.
This learning, say A for apple before, or A for algebra, A for say alphabet, A for say all. You know, I got various kinds of response from the participants. But when all the learnings are going in the cloud, they are getting the gist, not disclosing the who is Tufan Shah. Your data is not disclosed. Your identity is not disclosed, right? Clear? But they are making global model where they are taking a average. Which model should come first? For Apple or for all? Or say G for good or G for global? So when by this process they are developing a initialization model. Are you getting my point? Initially,
yes,
before you start, there is some initial model where they have written, Google has written, when you update the software, they write A for say Apple or G for good. Good morning is very popularly used word in WhatsApp, right? Agree?
Agreed, sir.
Now, this WhatsApp company, they have done a lot of survey from all of them. They have observed G for good morning. So after 1 month update, that okay, everyone is using, so they update the software for good morning. So, but in case of mobile phone of Sun, G4, it can be good. After 2-3 downs, okay, machine will see Google, this is called Gboard, keyboard, Gboard, right? That will see, okay, Tufan is using good. Initially, they have given good, but Tufan writes BG for say global, right? After 2-3 iteration, this code will start writing G for global, G for global. For say someone in my mobile, or I give G for say God. In my mobile, it is giving God. But initial model is coming from the Google. Is it clear? It's very difficult to understand, but so this is called local learning. This is called global learning. I'll be giving some more example. I'll be giving some more example. It will be more clear to you. So see, this is a blue pattern, blue circle. Someone asked a question. Yes, depending on the users of the word. The blue pattern, WhatsApp company is given the blue pattern. Blue pattern means A for what they will write, B for what you will write. So they have done a survey for 1 month and active survey, not local survey. So after that, this is the mobile phone, my mobile phone, right? Devashish mobile phone, right? So this learning circle is coming to my mobile phone. So I was writing a lot of keywords, right? After that, this is my new pattern is generated. Earlier pattern was blue pattern circle. After say 7 days used, this blue square screen is coming. This is my pattern. This is the pattern of Devashish, right? So this pattern is coming to this B model. B place, right? The B place, B section, it collects pattern from all the users, all the WhatsApp users. So this is the pattern of Devashish. This is the pattern of Babri Ghosh madam. This is the pattern of Tufan. This is the pattern of Nilanjana madam. This is the pattern of Moa madam. Ultimately, this will make a mixture, right? And they will develop a centralized model. That is C square kind of green. This model will go to C, and ultimately, this all blue will be replaced by this, this kind of this structure. So by this way, whole system, on the whole system will become trained. Okay. So a new pattern will come. So this all blue will be replaced by this blue circle. For example, I can give one example. Earlier, what do you write for C? Anyone? What do you write for C?
Cat.
Cat. Yes. Please tell. Please feel free to tell.
Calcutta.
Calcutta. Yes, correct. Do you know what is the most popular C for nowadays in 2021? C for?
COVID.
Yes, you are correct, madam. So initially it was blue, C for Calcutta or C for cat. But after because COVID is so much around us, we're all anxious. So C for COVID. This machine learning will understand more people is writing C for COVID. So they will write in the frequently listed pattern of NLP, C for COVID. Is it clear?
Yes, sir.
So this is the, see, your privacy is not disclosed. Your privacy is within your mobile phone. But ultimately, this is the collaborative fashion. This is the collaborative model. This is the local model, local learning model. This is the global learning model. Is it clear?
Yes.
So by this process, this is called federated learning. This is the beautiful learning is actually coming in the 5G and 6G network. Even in 5G is also there. 6G is coming in a better way. Because this computation takes a lot of time, and you know that 6G is coming with quantum communication. So speed will be much more higher. Okay. So this computation is done by the quantum computer. Already many of us, I use quantum computer. Okay, I have the password of quantum computer. I can log into the quantum computer, right? So I can write my own program in the quantum computer. Quantum computers are placed in a various part of the world, maybe in Melbourne, maybe in UK, maybe in US, many other countries, right? By this process, this learning system happened, right? Clear?
Yes, sir.
See, what we wanted to mention, see, this given clearly. Initialize the model. Training happens in the local level. So this mobile ABC 3%. Everyone has a default pattern. This is ultimately going to the aggregation, what is called information aggregation or information fusion. They develop a aggregation model, and using this aggregation model, our new model, this triangle, blue triangle is developed, and this blue triangle is coming to the whole system. I've given the same example in various ways, right? So that you can understand what is the beauty of this federated learning in 6G network. So this is called privacy preserving machine learning. Federated learning is called privacy preserving machine learning. And this model update do not happen every day, once in a month. Do not think that model is updating. I think you have seen your WhatsApp updates. So it happens once in a month or twice in a month, not every day. Okay. See, we can give the weightage also. I can give the weightage 1, weightage 2, weightage 3. Ultimately, the combined weightage is going to the cloud. It is called weight-based learning. Machine learning, in neural network, we use weight, W1, W2, W3. Various kinds of weightage we can give. Either we can give everyone equal weightage, or we can give weightage to the senior citizens, or we can give the weightage to the teenagers. So it's based on the algorithm to algorithm, right? So there are various types of there. Lot of pattern recognition, NLP research is there. I think some of you have asked what are the research areas. Lot of NLP research area is open here, right? For privacy preserving system. So even if the temperature of Calcutta, or temperature of Mumbai, from the keyboard of the user, we can get what is the temperature, and ultimately we can, from the keyboard of the human being, we do not need to put the sensors. Using the keyboard of your mobile phone, the Google can understand what is the temperature of Calcutta, or what is the temperature of Mumbai. So this kind of competition is happening, and Google is doing a fabulous job. Google actually started this advanced federated learning. So these things are actually happening, and yes, this is going to be the future of machine learning. Okay. Already I mentioned the Google keyboard or Gboard. They have a baseline model, the initialization model, then our own pattern, federated learning model. This is the F stand for federated learning. This is the symbol of federated learning. Okay. The training cache, training will be happening in the keyboard, and ultimately the inference model is here. What kind of inference you are getting from the training database, right? So by this process, your recommendation is coming to your WhatsApp message. Hey, I have headed out now. Are you in the lobby? So some automated message we can give. So this is all part of machine learning. So we are giving machine learning to the keyboards, and NLP research is very popular in terms of this situation. Because we want very fast life, right? In the study I mentioned, smart city means fast city. So we do not have to type A, B, C, D, okay, federated learning, or cyber security, CYBR, security, SECUR, RHY. If you write C, the machine will automatically understand C for security, right? Or C for cyber. So this is the auto prompt is coming from these areas. So these are the areas actually. Now come to the healthcare, all the drones. Drones and healthcare companies are actually working together to evaluate the process, and see each and every. This is Devashish's health data. This is a Tufan's health data. This is a Bhabri Madam's health data. Everyone health data. It is not non-disclosable, right? But when we go for one hospital to other hospital, we have to consider for EHR, electronic health record transfer. EHR, electronic health record transfer. EHR. So by this process, we are transferring the health record from one server to other server. So this is the point of transferring data. from one place to other place. Okay. But your identity will not be disclosed. Your identity will not be disclosed. So this is the beauty of federated learning, where we can transport the data from one hospital to other hospital. Because see, you have done some chest X-ray for COVID. So you want to change your hospital. Why you will go for second X-ray? So you simply transfer the health record, EHR. Hospital A will transfer the data to the health hospital B. So we do not need to go for second level of X-ray. Okay, because that will damage. Multiple X-ray will damage your heart or health, right? Or chest. So these are the case studies are there. So yes, blockchain also is another very interesting thing, which is coming up with the distributed ledger. Also the BCI, computer interface. Nilanjana madam, are you there?
Yes, sir, I'm here.
Yeah, please see this one, your area. I think Mahmood Hussain sir is talking about BCI.
Absolutely, sir.
So I think I have shown you some video where the professor was thinking of some drone and the drone is flying. It's absolutely amazing, right? So the brain computer interface, I think you are getting a lot of lectures, participants from our Professor Mahmood Hussain sir and his team. So brain computer interaction is very important. And that is also privacy preserving. So it is your drone. I can operate my own drone, but unless and until Nilanjana madams give me the permission, I cannot operate hard drone, right? So this is the privacy preserving function. Clear? Hello.
Yes, sir.
Yes, sir, absolutely.
So brain computer interface, blockchain, distributed ledger. So these are the components of three-dimensional integration. See, distributed artificial intelligence. Also, intelligent radio, multi-sensor. I have mentioned, right? Multi-sensor, multi-robot connectivity. So these are the new areas are coming up. Okay, and these are all amazing. And I am happy to see that IEM is organizing this amazing FDP, because BCI interface is one of the very interesting area. I think I have seen yesterday our friend has given the talk on NLP, right? So NLP is also playing a major role. So this all the technologies, distributed AI, intelligent radio, real-time edge analytics. Okay, these three things makes the privacy preserving system along with the blockchain-based network. So these are the issues. Okay, where authentication is what the issues are there, access issues are there, malicious behaviors are there, encryptions are there, communications are there. So these are the techniques are used widely to preserve the privacy of each and every individual. There are billions of users. We have to take care of each and every individual. Then only we can say the privacy meets 6G. So job. That's why it is job we made when privacy meets the the 6G network. So we have to provide the machine learning, which should be privacy preserved, right? Otherwise, there is no point of discussion, right? So privacy must be preserved at any cost, right? So it is another thing, collaborative learning. So if you see, privacy preserving machine learning for machine learning did privacy preserving. Machine learning is itself used for privacy preserving. Also, machine learning also can help to stop the attack. Another very interesting thing, you will be laughing, you will be, it is amazing. People are using machine learning to attack the system. Can you believe it? Machine learning itself is used to attack the system. So this is another very interesting area. Machine learning is used to attack. Machine learning based attack. So it is, mind to mind game. So there are various models are there. I'm not going in various attacks. So I want to mention that category 1, category 2, category 3, there are various kinds of privacy models. And see, there are category 1 where ML meets the target for privacy protection. Okay, there are various attacks. Category 2, ML enhance the privacy. Third one, ML-based privacy attack. Machine learning is itself is attacking. So you have to design the intelligent tool. Right? There is always a fight, you know, the cryptographer and encryption, decryption model. I think everyone know that. That's why cryptographic algorithm we are changing every day. So attacking is coming all the time. So various 3 types of categories are there for attack and attack mitigation. Okay, I'm not going to these things. So some attacks are called inference attack. So your inference will be changed. Some attack is called linkage. You can change the link. I want to link to one side, then they link to the Nilanjana madam. So link will be going to the wrong person. So various linkage attacks are also involved. There are various privacy preserving attacks and amendment rules are coming up. So privacy data management is one part of cyber laws. I think if you see the cyber law, it is coming in a big way. Okay. So there are various attacks. I'm not going to this. Yes, ultimately we have to preserve underwater, terrestrial, real, as well in the space. 4 levels we are working, right? You know, quantum communication. Some of our Calcutta scientists of Jadavpur University, she's done you know that he worked in Bangalore. I think Jawaharlal Nehru Research Institute. They worked with Day3 to develop the quantum key encryption for the quantum key distribution for satellites. And that quantum key can be connecting all the things, all the 4 layers. That means underwater, terrestrial, real, as well as the space. 4 layers it can cover. So quantum key distribution or quantum attacks, quantum key distributions are very interesting. Quantum computing is also a very important area. If the quantum computing comes, it can break everything. You know, quantum computing is already in the market. Those who are interested, they can contact me. I'll show you. I can give you the password, no problem. So if the quantum computing comes, your well-known algorithm like RSA, that can be broken within fraction of a second. So this is the time of quantum machine learning. Okay, quantum resistant hardware and quantum cryptography. So quantum machine learning, quantum federated learning. This is another interesting area. I'm talking about some open areas. Some of you have asked, what are the open areas? These are the open areas. Okay. Because quantum computing has 3 bits, 0, 1, and 3rd bit. So it is a power of 2 to the power 3. So 2 to the power n power. So complexity you can understand. N times it is faster. Okay. So you understand the quantum computing is coming in a big way, and I'm also slowly working in this area of quantum cryptography. And this is a very interesting area is coming up, and I think many of you can jump on it. Another very interesting is quantum blockchain. This is another very interesting area. Quantum blockchain is playing a major role, and you know that it is written that quantum computers can capable of breaking 99% of encryption. Okay. So what are the encryption topic you have heard? What are the biometric encryption? You know that can be destroyed in a fraction of a second. So we have to go for quantum-based machine learning, quantum-based secure, and quantum-based federated learning, right? So with this, I want to stop. And these are some of the very interesting areas of machine learning. So some of the references there. I'll provide you all the slides. And thank you.
Thank you so very much, sir, for this wonderful talk. And we got to learn so much information about the new technologies which are evolving around the world. I personally wish everyone will be having a smarter celebration of Diwali this year with the suggestion you gave about drones being used for lighting, and that will surely take down immense amount of pollution level from the air as well as whatever is coming up. And I request all the participants, if you have any questions, please take help of the chat box, or as well as you can unmute yourself and you can ask your question directly to sir. It has been a very interactive session, sir. So throughout the session, I guess the participants have interacted. They have answered to your questions.
Yeah. Even you have mentioned the Diwali time, November, Delhi, especially Delhi becomes very populated. Means
Yes.
pollution.
The air
And
pollution goes high.
yeah, so they are doing a lot of precautions. So hopefully this lighting system will become popular. Yeah.
We also hope for the same.
Yeah.
And thank you so much for introducing federated learning and how it is meeting 6G, and about drone doctors. You have talked about, how drone is being used in every aspect of life, and how drone is playing a major role in making a city smart to smarter to smartest. We got a fair idea about it from today's session. So thank you very much, sir, for all this information. And I would request Tufan sir to please share your screen and show the club.
Thank you, everyone. Thank you.
Sir, since it is in the virtual platform and we are not able to meet and greet you physically, so we have prepared a virtual club for you. So please accept it from our end.
I accept it. Glad to accept you. Thank you for giving me the opportunity to share my thoughts. I hope I have ordered. I have taken a lot of time, 3 hours time, 3.5 hours. So
we didn't
thank
even,
you.
Get to look at the watch, sir. We were so glued to whatever you were saying. So thank you for making this 3 hours so very wonderful for us.
I think they have asked for email ID. I'm sharing my email ID. No problem. In the chat.
Thank you. And there are a few, a lot of appreciations coming your way through the chat box. All right.
I'll share my WhatsApp number also. No problem.
Thank you, sir. Thank you so very much. So to all the participants, sir has already given his WhatsApp number as well as email ID, so you can reach out to him whenever you need his help. As sir has said, he's like Linux, not Windows, so everything is open to all.
See, ultimately we have to bring make a sustainable world, and all the technologies. No one person can do it. Everyone should work together for your country. That is our target. Thank you.
Thank you so very much. Thank you for your time.
Thank you. I'm closing it down. Bye. Tufan, bye. Thank you.
Thank you so very much, sir. It was very, very beautiful, sir.
Absolutely. It was a wonderful session, sir. Thank you very much for accepting our invitation, sir.
Thank you.
Thank you. Bye, sir.
Bye.
Thank you to all the participants for being present in these 2 sessions. The 3rd session of the day and the 9th session of this particular FDP will be starting from 2 p.m. today. So either you can stay in this link or you can take a 1-hour break, and we will be again starting from 2 p.m. Also about the attendance cum feedback form, it will be shared only through the Zoom chat box between 3 and 3:30 p.m. and the attendance will only be accepted between 3 and 3:30 p.m. So I request all the participants to be a bit vigilant in this time span. And whilst you are filling up the attendance cum feedback form, please make sure you're using the same details which you have used while registering in the AICTE ATAL portal. So thank you, everyone. Thank you from our end. We will meet again at 2 p.m.